Hi, welcome to Material Issues in Mechanical Design. My name is Sue James, and I'll be your professor for this course. I wanted to tell you a little bit about myself during this introduction, and this is an example of the kind of introduction I'd like you to give to your classmates and to me through the discussion board online. So as I said, my name is Sue. Please feel free to call me Sue through the course of the semester. If you prefer Professor James or Dr. James, that's okay too. So I came here in 1994. Before that, I worked for a year in industry for a company called Failure Analysis, which is now called Exponent, basically doing forensic consulting and engineering work in various fields, but in all cases related to material science, the subject of our course. Before that, I was in school. I did my graduate work at MIT, Massachusetts Institute of Technology in Cambridge, Massachusetts. I studied polymers there and got a PhD in polymers. Before that, I went to Carnegie Mellon, where I studied metallurgical engineering and materials science, and I also did a minor in biomedical engineering. And in fact, biomedical engineering is really the area where I've always worked in materials science and engineering, applying those skills to the design of medical implants and other devices for the healthcare industry. You can see an example here of the kind of work that I do. This is actually a really old total hip replacement. This is probably a 20-year-old implant that I've been using as a demo for some time. But the reality is that the implants they implant today have a similar design. They're made out of metallic alloys, a cobalt chrome alloy and a titanium alloy, both of which we'll talk about some in class this semester, and a white plastic or polymeric material called ultra-high molecular weight polyethylene. And the research that I do in my laboratory is related to these materials. We have worked on developing a new form of this polyethylene material that is more wear resistant and better lubricated than the current materials. Let me show you one other example. This is an example of a total disc replacement used to replace an intervertebral disc in the back, again made out of metallic alloys and the same white plastic ultra-high molecular weight polyethylene. In the class this semester, we'll be studying the structure-function relationships of materials so that we understand how the processing of materials affects their performance and their properties, and get an appreciation of the sort of sophisticated aspects of performance, particularly related to mechanical design. I am married. I have two children, two little boys who are 9 and 12 years old. And I also enjoy a number of hobbies and things that I do when I'm not busy being a material scientist and a professor. I like to oil paint, and I also enjoy other fiber-based crafts like knitting and batiking and things like that. And then I guess finally, I'm also an administrator here at CSU. So I am the director of the School of Biomedical Engineering. And so in addition to doing research in the laboratory and teaching in the classroom, I also spend some of my time administrating programs.